Good morning. This is your stats sensei, Mr. Spensei, and this is going to be our classwork, and we're going to work with scenario one from our warm-up. Can't get no satisfaction. A rural county hospital offers several health services. The hospital administrators conducted a poll to determine whether the residents' satisfaction with the available services depends on their gender. All right, so services depends on gender. This tells me that we're probably working with a chi-square test of independence, especially when I sit there and go, hey, I have a table of values that make a 2 by 2 matrix because we always exclude the totals. So we have a 2 by 2 there. And that means it cannot be goodness of fit. Goodness of fit can only either be one row or one column. It cannot be both, multiple. A random sample, well, that's good. Of 1,000 adult county residents was selected from more than 500,000 adults living in the county. The gender of each respondent was recorded, and each was asked whether he or she was satisfied with the services offered by the hospital. The resulting data are shown in the table below. Use a significance level of 0.05, conduct an appropriate test to determine if for adult residents of this county, there is an association. All right, that's all I needed to know. We are specifically working with a chi-square test of independence. They want to know whether there's association between gender and whether or not they were satisfied with services. So we want to know, are services and gender independent? So the very first thing we need to do is go ahead and write our hypothesis. And to speed things up, I have. So we said services and gender are independent. So our HO, satisfaction with services and gender are independent. We always have to make that statement. We're always going to make it, and remember the HO will always be positive. And if they are independent, that means they are not associated. Ha, which is always going to be the negative statement. Satisfaction with services and gender are not independent, which means they are associated. All right, so let's go ahead and write our formula down. Our formula is chi-squared equals observed minus expected squared over expected. Degrees of freedom is rows minus 1 times columns minus 1, which in this case is 2 minus 1 times 2 minus 1, which is 1 times 1. So our degrees of freedom on this thing are just 1. Pretty small number of degrees of freedom. Random sample, when I look back, it says there were 1,000 adults out of 500,000. That's going to be important. The random sample of 1,000 was given. All right, we'll take it times 10, and it's less than 500,000. So we're good for the n is less than 10%, and we're good on having a random sample. Expected values, I need to go check that. Well, to do that, I need to input this into the matrix. So I'm going to take a moment and do that. All right, so we're going to go second matrix, arrow over to the word edit. And what size matrix do we have? Well, I need to press enter. And then we have a 1, 2, 2 by 2. So 2, enter, 2, enter. And I've already entered my data, 384, 416, 80, and 120. Once I do that, I need to go second and the button next to it and leave. I'm going to go ahead and run my test. So stat test chi-squared test, press enter. Go run the whole thing. And we get some values that are important. We're going to go ahead and note those down. We have our chi-squared value. So the probability that the chi-squared is greater than 4.1173 equals our p-value, and our p-value is 0.0424. They said they wanted us to use an alpha level of 0.05. All right. And 424 is less than 500. It's not a lot less than 500. And by the way, we can also look at our calculator and see that we have a degrees of freedom of 1, which confirms what we calculated. So we are going to, with it being less, our decision is going to be to reject. But back to those expected values that we haven't written down. So I haven't written those down, and we're going to go back into the matrix. So the second button, followed by the x to the -1 button. We're going to go to edit, but this time instead of entering the matrix at A, we're going to drop down to B. And there are our expected values, and we're going to just record those in the table next to the values they have. So we had 371.2, 92.8, and 428.8. And lastly, we had 107.2. All right. Now, please remember, we don't enter the total value, so that's why there's no expected values for the totals. It's only for the part inside the matrix. So we have all of that. We actually have our decision. We need to show our plug as to what did the calculator do. Well, the calculator, we only have to pay attention to the first and last one. So I need to pay attention to this one, my first one, and this one, my last one. So top left hand, bottom right hand. So chi-squared equals the observed 384 minus 371.2 squared over 371.2. Observed minus expected over expected. That's the first one. Plus dot plus the last one. 120 minus 107.2 squared over 107.2. All right. So the p-value is 0.042. Really, I should say 0.0424, because that's what we have. We rejected the null. There is sufficient evidence that alpha equal 0.05 to suggest that gender and hospital satisfaction are not independent. That's just a restatement of our HA. Satisfaction and gender are not independent. We just always restate our HA. Matter of fact, if we wanted to, we could swap that phrase. Instead of saying are not independent, we can say that they are associated. So, saying the exact same thing, the p-value is 0.042. We reject the null. There is not sufficient evidence that alpha equal 0.05 to suggest that gender and hospital satisfaction are associated. Once again, I just restated the HA. Now, whichever way you choose, if you choose to go are not or are, do it every single time so you don't confuse them. But up here, you have to have their independent for the positive statement, and you have to say not independent for the negative statement of the HA. The HO's got to be a positive statement. The HA's got to be a negative statement. Hope that helps you out. Hope to see you on the next one. And by the way, once again, on these conclusions, you only need one of them. All right. Look forward to seeing you on the next one. Thank you.